Hey everybody, this is going to be a longer video, so right now I'm going to say I promise I will put in the description links to timestamps for specific things that I talk about. Basically, I got a list of a couple things that I need to make sure I talk about at some point, and why not have them all in the same place? And then all you have to do is click different links in the description. But yeah, it was a long video. My first run of this was half an hour, and hopefully it will not be half an hour. I'll stop rambling now and get to it. So, this is what you've got in Canvas. You just had a bell work. If I can go back to it, the bell work, where this guy introduces basically how injection molding works. It is another type of manufacturing. It's actually used pretty frequently. It's good for making a lot of items quickly and fairly cheaply. If you're not making a lot of items, though, the molds are expensive and it might not be worth it. So I think there's a whole article, or not article, there's a whole little additional subtopic about injection molding in here. They talk about things like what I was just saying. If you have only a few parts, then buying a mold is going to be expensive. But if you have a lot of parts you got to make, like Lego uses this method. I actually put a video I found at the bottom here. If you're interested in watching that, it's kind of cool. But the thing about injection molding, and this is what I was kind of trying to get at with the bell work that I gave you guys. I said, hey, give me an idea about some things you might have to consider when you're doing injection molding over something else. And there's a whole list of things you have to consider when you're injection molding, when you're designing for injection molding. Like wall thickness. If you are heating and cooling material, which is what happens in injection molding, then having different thicknesses throughout your part could cause some problems with like warping, bubbling, and just your structural integrity has issues. But if you do need to have different thicknesses, try not to have these sharp corners. We're going to have filleting or chamfering to fix that. If you have sharp corners, you're going to have problems getting your mold to release properly. And you don't want that, because that'll waste material and time, and then you have to make a whole new mold, and it costs a lot of money. If you have a lot of thick sections, you can hollow them out and then use ribs to add strength. Instead of having these parts here all hollow, see how they've got these little walls in the middle of it? They call them ribs. You want to round all your corners on your part, kind of like up here, these corners here. You want a smooth transition? These have to be smooth transitions too, because you don't want anything getting stuck. And if you had to clean the mold, you would not want to have to go into tiny little 90-degree corners or even smaller. They give some recommendations on thickness. Then they talk about a draft angle. Same reason you don't necessarily want to have sharp pointy corners. You need to have a draft angle. Anything that's going to be vertical, at least compared to where the injection happens, it needs to be slightly angled, because you need to be able to let go of that mold nicely. 2 degrees, 3 degrees. I think Onshape automatically does 3-degree draft angles. You can always choose your draft angle if you want a steeper or shallower angle. Talks about embossing your text, so raising it instead of carving it in. And living hinges it talks about, which is really cool. Look at this. It's a thin, flexible, integral segment of material. And there are some pictures of those down here. Like, it's just, the plastic is continuous in here. It's not like it's two parts that pop away from each other. But if you fold and unfold it enough, it's going to snap off. Here's a contact case. Some of you guys may wear contacts and have seen this sort of flexible part. It's part of the whole thing. It's not like it's 3 or 4 parts that are held together with a pin or something. Anyways, we're talking about anything else over here. It typically produces parts with different tolerance right there. It tells all that stuff. So yeah, there's some really interesting stuff in here. You can 3D print living hinges. I've done that. They fell apart pretty quickly, in part because of the type of material that I'm using right now, and because of the way it prints, like line by line, layer by layer. Those layers can split from each other, especially if you're not careful. Like this right here. Oh, that'd be bad. That hinge is going to bend parallel to all those little layers, and it's going to just snap the layers apart. Anyways, that I've saved as a PDF. This whole thing I've saved as a PDF. They're both in here. Here's the injection molding PDF. Here's a animation that it tells you about in the injection molding PDF. I've linked it. Here's the guidelines without the pictures. Here's the PDF from the activity itself. All I do, by the way, folks, is I go up here and I say, okay, print. And instead of picking it as a printer, I say save as a PDF. And that's how I get them saved as PDFs. And you can print them out. You can print them on a printer. Anyways, to do, we're going to follow the directions after step 14 in here. So I'm going to scroll down to that. I mean, you can follow all these directions if you want to. They're written for Fusion, though. Every single one of these pictures is from Fusion. All the words and all the how to find these parts and make these things, a lot of that is specific to Fusion. And while yes, there are analogous parts of Onshape, it's annoying to follow directions written for one program when you're looking at a different program. Your interface looks completely different, even if it has the same basic tools available to you. So yeah, we're going to start around here together. All right. So yeah, the instructions use the word taper. This is a key difference in this particular unit. The word in Onshape is draft. Draft and taper, it's kind of the same idea. Basically, you have something that has like a slight angle inward as it goes up. All right. You can play around with the number of degrees. We're going to be adding an offset plane, loft. Basically, I tell you all the things that you need to know how to do, kind of. And then you're going to make your screwdriver case, and you're going to share that with me on Onshape. Or if you have questions, you can always just share your document. So let's take a look at the instructions. Extruding with a taper. It basically goes bit by bit through what you need to do to make this thing. So new component, a new design file. Basically, you just make a new file, which I just made. Create a pentagon, and then extrude it with a taper angle of -45 degrees. It's all in here. All the little parts are in here. All right, all you have to do is read through it and try to follow along, and be aware that maybe like loft will look slightly different in Fusion compared to Onshape, and the taper is called draft in Onshape, and this negative is going to be a problem, but I'll show you how to fix it. So let's talk about the basics of things you actually need to know to build this. You got to figure out how to make polygons first of all. So start a new sketch anywhere. I like to use top plane because I'm going to be making something that is vertical. New sketch on top plane. We've used the lines, the rectangles, circles. You probably used arcs by now. You may have used points. This is the inscribed polygon. And if you click the arrow, there's also a circumscribed polygon. What's the difference? Let me see if I can make, there we go. I'll just make 2 hexagons, one in each style. And oh, I can't line it up nicely. It's okay. All right, I'm gonna call the radius of each of these 1 inch. Oh, there we go. If you'll notice, the inscribed, that's the first one I made, has a circle inscribed in it. The circumscribed has a circle circumscribed. Inscribed is it's on the inside, it's tangent to the insides, and because the points go out farther than the midpoint of the line, this circle is tangent to the midpoint of every single edge. And so the radius of the circle is the distance from the center to the midpoint of any of these edges. The circumscribed, circum means go around, scribe means drawn, so you draw it around. The circle's drawn around over here. It's got the same radius as this one, but you'll notice this one looks a little smaller. And that's because the distance that's the radius actually goes from the point out to the corner, which is the farthest distance on the outside of the polygon from the center. If we line them up, you can see that the circumscribe, the one with the circle around the outside of it, is smaller than the one with the circle on the inside. So that's cool. I can make it look weird. I'm going to stop messing around. You can make them have, if you notice when I made these, I'm going to just keep using inscribe. It's easier for me to think about. The first click gives you the point, the center point, and the second click will give you how big it's going to be. And then you see it's got a 6 with arrows next to it, 6 sides. If I go closer to the middle, 5, 4, 3. If I go farther out, 4, 3, the largest, I think I can zoom out and show you the largest I can get is 50 sides. It basically looks like a circle at that point, but if you go real close, like if you do a 50-sided one and you scroll in, you can see that those are all just little line segments. Alright, let me make a pentagon, because I need to. Oh, wow, I zoomed way too far in. There we go. Let me make another one. Notice also these are all it's going to do the same kind again. If I were to do like an octagon, then the next one I make is going to look like an octagon to start with. And that's fine by me. Alright. Notice also these are all regular polygons. All the edges have the same length. All of the interior angles at each vertex are the same. That's what regular polygons are. To make irregular ones, you're going to need to use the line. If I wanted to make an irregular hexagon, for example, there it is. 6 sides, not regular, all different lengths, etc. Alright, there we go. Polygons. Check. Alright, what's next? Patterns. Okay, I'm going to do a quick review on patterns. I know I've done a video on this before, I just don't know, I can't guarantee anybody's seen any of these videos. You may have skipped that part of an activity or been sick that week or something. Patterns, real quick. I'm going to do this on the front plane so you can see what's going on. You can do this in 2 ways. I can make a pattern within a sketch. Let's say I wanted to make the base of my whatever, and I want to have a bunch of dots going around it in an orderly fashion. I'm going to use the linear pattern. Yours is going to have it automatically. I just use circular pattern, so that's up top. Linear pattern. If I click on my circle, you'll notice it gives me an arrow going up and down, arrow going left and right. If I click on the arrow, that'll bring it down. I'm going to tell it that I want 2 of those. You know what, maybe I can make it do 3. And then I'll just take the arrow and drag it back. And you can always dimension it later. See, there's a dimension right here. You can change that. You can change this one. Maybe I want this one to be 4. And then I can change that. You can always dimension it exactly if you want to. The other cool thing at this stage, if I wanted to, if I grab this square instead of the arrow, I can make it diagonal. And just do any kind of weird stuff like that. Or not. It depends on what you want to do. Anyways, that's enough playing around with that. You can also do circular patterns if you noticed. Oh, I'm out of the sketch. If you noticed, it was already on circular because I did that one recently. You can also do transformations. I'm going to just make a shape. Usually they're centered on the origin. I don't know if you can do a circular pattern centered on something else. When I open it, I'll take a look. There we go. I've made 2 line segments. Let's make a circular pattern. Oops. Circular pattern. Oops. Undo. I missed. It's getting late. I'm missing things because I can't see right. There we go. So there's a 3. I can make this go 8 times around, kind of like a pinwheel or something. Make it go 20 times. Ooh, and then it kind of intersected itself, so it's going to have issues. What about 10 times? Yeah, they kind of intersect. I can just make it go twice. Anyways, that's how you do circular patterns. So patterns, linear, circular. You can also, if I were to extrude, let's say I undo the 2 things I did patterns of. All right. Make a new sketch. Make a box. Extrude it slightly. And let's say I'm going to put a hole into it or something, or make something sticking out of it. Let me sketch on the surface. If I've already made a 3D feature, like like this, I can say, oh man, I wanted a whole bunch of those. I like the height of it, I like the shape of it, the size of it, I like the location of that one, but I want a whole bunch of them. If I go and look for, there's also a pattern tool in the 3D menu here. Linear patterns, circular, and curvy patterns. Do a linear pattern. I'm going to do not a part pattern, because it'll take everything that's attached to that, but a feature pattern. And the feature I would like to pattern is this extrusion here. I gotta tell it what direction. Let's say I want it to go this way, and this way. Oh, it only does one. It only lets me do one. I'm gonna have to do this twice. See, this is one of the downfalls. Second direction, there you go. I already did that one. There we go. Distance 1 inch. Instance count. Let's go 3 in that direction. And let's do instance. Let's change. No, let's keep the same direction. 5 in that direction. And then I'm going to have to make them a little bit closer together. And these guys kind of come off the edge. I don't like that. Let's make them a little closer together. And there I've done a linear pattern. I don't believe I can spin it around. If your part that you're trying to do, your feature you're trying to work with is centered though, you can click that center box, and what it'll do is it'll make it go in both directions on either side of it. Which is nice if you need it. What's this, apply per instance? I'll have to mess around with that more. I don't know a whole lot about that. I don't know if I can angle this one or not. You can also do circular patterns with this. Anyways, I'm not going to pattern. I'm not going to worry about this extrude. Let's get deleting some of these features. That was patterns. Hopefully a brief overview and review. Okay, next we're going to talk about making a shell. And you know what? That would have been a cool thing to make a shell out of. Alright. Shell. That's this guy right here. You got to have a 3D figure to do a shell. And what it does is it takes off a face. Like, let's say I was going to make this a box. And it's going to take this face off, and it's going to have just walls around it. Why won't it? Oh no, could not shell part with selections. Oh, well, let's not do that one then. Let's do this from the top. There we go. It's a box. You do this from the back. And the cool thing is, look at that. It actually shelled inside that right there. That's shell. And if you shell, there you go. It's kind of cool. You can also choose to make something hollow, which means that it's not going to have that opening, but the inside will be hollow. And to sort of see that, let me show hidden lines. Shading with hidden edges. So there it is. Let me hit check and zoom in, and you can see kind of that the that there's like a thickness, but inside is all hollow. Cool, huh? All right. Let's get back to a normal view, sort of normal. And let's take a look at some of these guys. That's a shell feature, a brief intro to shell. You can also change the thickness of it, just like with an extrude. You could change the thickness to be thicker or skinnier. You can change it to stop being hollow. Let's remove one of the top or something. There we go. I can change it to be 0.2 inches. That's thicker. 0.02, which is thinner. If I do this too thick, then it won't show anything at all, because this feature, it's going to overlap, and so it's not going to show at all. So undo any changes I made. Okay, let's look at the next thing, which is tapering and drafting. Oops, not that. Tapering and drafting. I was trying to be fancy and scratch it out. There we go. Tapered and drafting things. Let's say that I want to, see, when I extrude, normally, when I extruded this thing, it made edges that are exactly perpendicular to that plane that I drew on. So if I do that with, you know, my pentagon over here, all those edges are perfectly perpendicular. Right. But you can choose to draft it. It automatically picks 3 degrees. If you'll notice, it's got like a darker center, and if you look at it from the side, it looks like it's going slightly out like a planter or something. And so that makes sense. If this is the original, the dark shape is the original shape, matches up exactly with the bottom, then this extra part on the outside, that's because every single edge tilted out about 3 degrees. I could hit this opposite direction and make it tilt in. You can see that it's getting skinnier as it goes up, ever so slightly. And you can see what the original shape was. Matches up, but it goes inside of it a little bit. Okay? Mess around with the degrees. You can change 10 degrees. Let me go back inside. 20 degrees. Guys, with the pentagon, by the way, it doesn't look symmetrical when you do something like this, because unless you're looking at straight on an edge or straight on a flat, it's gonna look weird, especially when you get to the point like this. You're just like, wait, it's not symmetrical. Anyways, it bothers me slightly when I'm working with odd-sided figures. The cool thing, though, is that you can, like, if you get this degree level high enough, it makes pyramids. It's an easy pyramid. And the extra cool thing is I can do the same thing on the back side here. Do an extrude with a draft and switch it up and make it, oh, I don't know, a slightly shallower thing, but let's only go about 1/2 inch or even 1/4 inch. And it kind of looks like a gem that's been cut with facets in a purposeful way. So that's an easy way to make a gemstone. Alright. Drafting is cool. You can make all kinds of shapes that'll injection mold nicely. I'm going to look at this sketch again. One thing I need to show you how to do is make an offset plane. So, bear with me, I can't see the mouse through the microphone stand. There we go. Alright, so making a plane, like when you open a document up like this, you're going to have the origin, a top plane, a front plane, and a right plane. You can see that plane symbol next to those guys. I could draw on this plane a sketch. I could draw a sketch on the front. I could draw a sketch over here. Once I extrude something, I could use any of the planes I create to draw a sketch. There, one, I could draw a sketch up here on this surface. I can't see. I'm clicking on all the edges now. No. It's showing me hidden edges and I can't pick the surface. Come on. There we go. I could draw on that surface I want to. I could draw on an angled surface I want to. There's a sketch plane I could make. But let's say I don't want to draw on something that already exists. Let's say I want to draw something that's off in space a little bit. I can create a new plane. And if you look at this plane symbol, that's the symbol right there. I'm going to offset from the top here. The normal setting is offset, and it goes offset by 1 inch. So basically I'm making a plane that is 1 inch away from the other one. And so you can see it kind of floating above there. You can change how far away it is. You can change it goes above or below. I'm going to go ahead and keep it at 1 inch for now. And now I've got a second plane where I can draw stuff on. So let's do some more polygons up here on this plane. I'm going to make a hexagon that's slightly smaller than this one, maybe at an angle. Oop, hexagon. I'm going to make something with maybe 3 sides, would be cool. Triangle-y. Ooh, that's going to be weird. That's cool. Let me make a box over here. Yeah. Alright, cool, weird stuff. Oh, hold on. I don't want that box. I want a center point box, so I can kind of aim for this. Not perfect, but it's close. Okay. So I made a bunch of things lofted up above like that. Not lofted, but on a plane that's lifted up like that. I can use, let me see, the loft sketch feature. Yay! Alright. So what loft does, it takes basically your 2 profiles, your 2 sketches, and it kind of makes these smooth edges between them. And what that looks like if you've got the same number of vertices is you might get something that's twisty. You have different vertices, you might get something weird. If you go to a circle, ooh, which I need to do, hold on. Gotta make a circle. Let's put it above that octagon down there. And approximately, yeah, that's whatever. Cool. If you go to a circle, you're going to get kind of a smooth top. Loft. You got to pick your two sketches to go together. Let's bring this hexagon up to this hexagon. And there it is. Notice all the corners decided to pick to go to the next corner up. I can change that. I can say matching vertices, and I'm going to pick this vertex and that vertex. I want to go the other way. Or this vertex, and let's go over 2. Ooh, you're getting some fancy twisting going on over there. Alright. What if you have, I've got to show my sketches again, hold up. Sketch. Okay. What if I have different number of vertices? Well, play around with it. Weird stuff indeed happens. You can look at this one. It looks like it tried to do like 1 point to one, like this vertex to that vertex, next vertex to the next one over, the next one to the next one over, but then when I get over to here, I don't have a vertex that hasn't been used on the top, so what it does is it just sort of splits difference, and these three kind of line up along the bottom, which gives an interesting effect. You may be able to change that. I have not figured it out, and I don't want to waste y'all's time right now messing around with it, because it's already getting late. That's what happens there. Cool. Another loft. To the circle. And it's hard to tell with these lines showing, but it's actually pretty smooth looking as it gets near the top. Like these corners are less distinguished and sharp as it goes up. Let's make it shaded without edges. You can kind of see that the edge fades as it gets closer to the circle. Same thing here, these edges are flattening out near the top. Anyways, cool beans. I'm not going to do all of them because, again, I'm running low on time. That was the only other thing I wanted to show y'all how to do. The instructions for what to build, they start at like number 15. New component, so make yourself a new design. Maybe call it 1.3.4. Screwdriver case. Maybe put your name on it. It's up to you. Your name is already in the list when I look at your files. Alright, so it says create a pentagon. Extrude it with a taper of negative 45 degrees. Positive 45, what positive looks like is it gets wider as it goes out. So all you have to do is, if you remember, let's see, oh, that's something else. We'll go to the next one, this one right here, yep. So remember originally, the draft on this was like going out instead. So just flip it to going in. Okay? And I kind of did this really quickly in the other video. I don't know if I want to give it all away for y'all right now. But yeah, I'm running out of time. But you can see I followed the directions. What I did is I went along as I was eyeballing it and checking to see if it looked kind of like it was supposed to look. I don't believe they have any measurements through the whole thing here. It might happen towards the bottom. If it does, then you can go back and you can edit your dimensions parametrically, which is nice. And that is that. Guys, if you have any questions, let me know. Y'all stay safe and healthy. Stay warm. It's below freezing today. Woo-hoo. I like the cold from Massachusetts, originally. Alright. Yeah, let me know if you got questions, and comments and whatnot. Let me show you this close up, and that'll be the end of my video. You can see what I did for it. So I did the same kind of things before. Look, irregular polygon. And again, look, it looks weird when you're not looking at it from an edge or from a flat. But yeah, I made a pentagon. I centered it at the origin so that everything else I centered above it, I could center over the origin, and it would snap through the geometry. I did an extrude of 45 degrees going inward. I changed my direction. I only went a little ways because I was like, I gotta match kind of what this thing looks like in the activity. Alright? I said, okay, let's, at the top there, we're taking that pentagon, we're going to extrude it, we're going to have a smaller draft angle. let's make a plane slightly above it, put a circle on it, and oops, and loft the pentagon up to the circle. Cool. Let's extrude that circle up and give it a little bit of a draft. And we're going to fill it that tippy top, and then it'll tell you at some point to extrude the bottom. And I was going to walk through the whole thing with y'all, but really, I want you guys to work on it. And if you get stuck, to let me know. Alrighty? Alright, now I am signing off. It's been half an hour. Have a great afternoon, evening, morning, night, weekend, whatever day it is, whatever time of day it is. Yeah, bye.